Let us see the tsunamis. They are the seismic sea waves. A tsunami is a seismic sea wave. Tsunamis are series of huge waves that can cause major devastation and loss of life when they hit the coast. The word tsunami is a Japanese word which means harbor waves. The possible causes of a tsunami are an underwater earthquake with the Richter scale magnitude of over 6.75, or a submarine rock slides, or a volcanic eruption, or if an asteroid or a meteoroid crashes into the oceanic water masses from space, tsunamis are formed. A tsunami starts when a huge volume of water is shifted by any of these underwater mechanisms happen. When such a large volume of water is moved, the resulting wave is very large and can be spread over an area of thousands of square kilometers. Tsunamis can travel from the point of origin to the coast at great speeds. The speed may be as high as 1000 kilometers per hour in the open ocean. This is the speed with which a jet aircraft travels. A tsunami can move from one end of the ocean to the other end in a few hours. Fortunately, tsunamis are very rare, with approximately 6 of them hitting the coast every century, most of them occurring in the Pacific Ocean only. With the advancement of technologies over the years, tsunamis can now be detected before they hit the coast, thereby reducing the loss of life. Mega tsunamis may occur when asteroids hit the ocean or when volcanoes erupt. The amplitude of a tsunami depends on the size of the original disturbance and also the distance travelled by the waves. A tsunami wave behaves much as the same as the widening circle radiating out from a pebble sponge. As the circle widens, the wave's crest lengthens and its height decreases proportionately to the square root of the distance travelled. After about 12,000 kilometers, it reaches the minimum amplitude. After this distance, it starts focusing again under the influence of Coriolis forces and the curvature of the earth. At sea, a tsunami is hardly noticeable even though it travels so fast, typically rising less than a meter over a period of 10 to 30 seconds. Such movement is easily concealed by the local waves. That is why many a time we may not be able to see this movement of tsunamis in the satellite pictures very easily. The speed of a tsunami wave is limited by the depth of the sea to about 450 knots in the Pacific Ocean, that is roughly about 830 kilometers per hour. A tsunami of 4000 meter deep bounces off the continental shelf, producing a variety of waveforms. The continental shelf of 100 meters is a very shallow area for all these waves. Hence, they easily rise, form steep crests and show very large horizontal water movements. This may make them run over all low-lying areas, rip boats from their moorings, and may bear the sea to a depth of 5 meters or splash against the coast to a height of 20 to 30 meters. You might have seen during tsunami, the water might have flown over to the first floor, second floor and sometimes third floor of the buildings in the coastal areas, and many of the resort hotels are all damaged by the wave heights. The first tsunami wave is not necessarily the worst tsunami wave. Earthquakes and tsunamis could be monitored by sea-based monitoring stations. By placing sensors on the bottom of the sea, large waves could be detected. Normal storm waves do not reach deep enough, but a tsunami's long wave would, even though its amplitude might be very small. By means of satellite communication, the early warning signals could be transmitted to a tsunami warning center. Waves have tremendous energy. These energies have both constructive effects and destructive effects. Let us study the details of the waves and the tides in the next modules.